So hello everyone, welcome back to the channel. Today we are going to solve the problem distinct difference. So given an array of length n, for each index I1 to n, find the difference between the number of distinct elements in its left and right side in the array. So let's discuss with an example. So here is given an example. So like we are given like array 4 3 4 3 2 4. So like number of elements like this 4, when we are at this 4, number of elements present here are 0. Number of distinct elements are 3, 4, and 2. Because 3 and 3 are repeated, we will take it once. 4 and 4 are repeated, we will take it once. So number of element present are 3. So on left side it is 3, on right side it is 0. So difference between them is 0 minus 3, which is equals to minus 3. So at 4 we will have minus 3. Now similarly we will go at this point. Just like So we will go at this point. The number of elements at 3. Number of elements are here 1. And number of distinct elements are 3. Like 4 repeat is 2 times. 3, 2, 4. So 1 minus 3 is equals to minus 2, which is equals to minus 2. Next, we will come here. Number of distinct element 2. Number of distinct element 3. 2 minus 3 is minus 2. Similarly, we will come here. Number of distinct elements are 2. Number of distinct elements are 2. So 2 minus 2 is equal to 0. Similarly, when we'll come here, so number of distinct elements are 2. Number of distinct elements are 1. So 2 minus 1 is equal to 1. So here answer is 1. Similarly, at last, what will happen? Number of distinct elements are 3. Number of distinct elements are 0. 3 minus 0 is equal to 3. So this is the array 3. So this is the array that we got, like minus 3, minus 2, minus 1, 0, 1, 3. So this is the array that we got. So like, how can we approach this question? So brute force way of this question, like what is a brute force way? Brute force way is we go to every index, like in this array. If I go to in this array, if I go to this array, so let's say I come to this index 4. So number of elements are here 2. Number of elements are here 3, distinct elements. So what will I do in brute force algo? I will go to every index, and for every index, what I will do? I will traverse in left direction. I will traverse in right direction and count the distinct elements. So like if left is equals to I minus 1, let's come here. And I will go until left is greater than is equal to 0. And I will count the distinct elements. By adding in a set, what we will do, we will store the unique elements. So we will get the, like we will insert all elements in set, like array of left. We will store it. And in this left part, we will get the set size. Set size is the unique element. Now, similarly, we can create ST2, and similarly, we will traverse in right from I plus 1 to n. And for every index, we will store in set, and we will get this. Okay, so left side, right side. So at the end, what we got? Left and right for every index we will do. So this will take big O of n square. Now, someone will think like, why we are taking big of n square? It should be log n. We are taking unordered set. So unordered set at approximately take big of 1. So we will take big of n square. So we have to optimize this approach. So we will optimize this approach using the suffix array. Like how can we maintain? So let's understand how we create this suffix array. Like here, initially it is 0. Why? Because number of right elements are 0. Okay. Now we will insert this 4 in set. Next time we will come to 2. Now 2, number of element in set are 1. What will set store? Set will store unique elements. Set will store unique elements. So we will say, we will add 1 here. Now, next time, we will add this 2 here. Now, similarly, here we come 3. Now, here number of elements are 2. So, here it will 2. Now, what we will add? We will add 3 here. Now, we'll come here at 4. We are traversing from right to left. And we will come 4 here. Now, we'll try to add 4. When we'll try to add 4, this 4 will be added once only. So it will remain 3 size only. So this will become 3. This will become 2 and okay. This will become 3 only. Now, next time when we come with 3, 4, 2, 3. When we add 3 again, so only one time it will be added. So it will become 3 again. So 3. Now when we come with 4, again 4 is already there. So it will already be added 3. So what this suffix array information give? This suffix array gives us information about that how many elements are after this point. How many elements are after this point which are distinct. Like if I ask about, let's say I am at index 4, like I am at index I, let's say. So what is the suffix of I plus 1 information give? Suffix of I plus 1 information gives all the distinct elements that are present. Why? Because we were traversing from right to left. So we are counting all the distinct elements. Similarly, we can maintain the prefix array, but we will not maintain the prefix array. It is not required. Why? Because while traversing the array from 0 to n minus 1, we will take the insert every element in set, and whatever the set size we will get that. So this is, so that's why prefix array is not as such required. Okay, so we have to optimize, we are not taking extra space. Okay, so like this is the approach. So like let's code this approach. Like here we create a suffix array of n plus 1 size, and like for n plus 1 size, so that last element should have 0 element. That's why. And unordered set and st. Like what we will do, like here we store the unique elements for while traversing from right to left. So while traversing from right to left, we will go to every position, and what we will do, like suffix of I is equals to st dot size, like, and then st dot insert ai, like that we were doing, like whenever we are traversing like 4 3 4 3 4, whatever example is here. So we are initially our set size is 0. So we will add 0 here. Now we will add this 4 in here. Now 4. So set size is 4. We add 4. Now we add 2 in the set. Now set size is 2. We will add 2. Like 1 size, 2 size. Like we are getting number of unique elements on the right. Okay. Now we will clear this set because our work is done. Our suffix array is created. Now what we will do? We will create an answer array. Now we will traverse the array. Now left side is st dot size. So whenever we are traversing from the array, let's say I am at an index here. So our set size will be 4 comma 3 here. So 4 comma 3, and this suffix of I will store the number of elements that are present on right side. So we get left. We have got left as well, right as well, and we will subtract them. So like left is equals to st dot size, and right is equals to suffix of I. That is ith index saying what is my suffix, what are number of distinct element add. Suffix is denoting like that. Okay, so like I can write here number of distinct elements present ahead me, we can say, and answer dot pushback left minus 8. And now we will insert this element which can act as a left point, left extra distinct element for next index, and at then we will return this answer array. Let's try to compile in the code. Let's submit the code. I have done this for submission because I was finding the smallest code that I can write. So this was all about this very easy question, like based on suffix or prefix array. You can create prefix array as well, but as such this is not required. So we will, when we will traverse, we can create this suffix array, and that's all about this question. So thank you. Have a nice day.